Hello student, today we are going to learn the topic motion of the art. So let's begin with the definition of motion. What is motion? The act or the process of movement of any object is known as motion. And art is also moving, so art has motions. The movement of the art is known as motion of the art, and we have two types of motion: rotation and revolution. Rotation means when the art rotates on its axis, and revolution means when art revolves around the sun. Here you have the picture of revolution and rotation. And next we have definition of motion of the art about its axis. This is what we know as rotation. So art is rotating from west to east direction, and the direction of this movement varies with the viewer's position. From the North Pole, the rotation appears to move in counterclockwise fashion. Looking down at the South Pole, the art rotation appears clockwise. So, this clockwise and anti-clockwise is due to the positions, viewer's position. Next, we have some more points regarding rotation of the art. The art rotates once in 24 hours. That means to take a complete round, to take a complete rotation, it takes 24 hours. Art's rotation is responsible for this daily cycle of day and night. If there is no rotation, then we won't experience this daily cycle of day and night. At any moment in time, one half of the art is in sunlight while the other half is in darkness, because all part of the art cannot receive sun's heat as it is spherical in shape. When the art rotates, we get day. When the art rotates, then we get day and night. The age dividing the day and the night is called the cycle of illumination. Cycle of illumination is the dividing line of day and night. You can see here in the picture, uh, sun's light is receiving in one half of the art surface and one half is not receiving. The side which receive the sunlight is day, experiencing daytime, and the other half which don't receive sunlight is experiencing the nighttime. Next, we have this rotation dictates the length of diurnal cycle, that is day and night. The art rotates on its axis, that is deep, over about 23.5 degrees. That means art axis is not straight, it's tilting, and angle of inclination is 23.5. The art rotates at approximately 15 angular degrees per hour. In 1 hour, it moves 15 angular degrees. When we discuss in previous class latitudes, so every 15 angular or every 15 latitude to move, it takes 1 hour. So the art surface move at equator at a speed of about 467 meter per second, or slightly over 1675 kilometer per hour. So this is the speed of art at equator. Next, we have the second motion of the art, that is revolution of the art. What is this revolution of the art? The art revolves around the sun is in an elliptical orbit, is what we know as revolution of the art. Here we have solar system and all planets are moving around the sun on their elliptical orbit. Here we have some more important point to remember. some more point to know about revolution of the art. It takes 365 days and 6 hours to complete one revolution, and distance between the earth and the sun changes due to revolution. During this revolution, the distance between the sun and the earth uh, doesn't remain same everywhere. Somewhere the distance is close, somewhere distance is far away from each other. So this change of distance causes a change in season. Not only this, uh, we have another reason for causing of season. As the earth revolve in an elliptical shape, as the earth revolve, it get closer sometime, earth and sun closer to each other sometime and farther away from each other. So sometime earth is very far away from sun and sometime it's close to the sun. So the angle that the sun hits the earth causes the season. Sometime uh, every part of the earth where sun's heat receive is not receiving the same amount of heat, as somewhere sun heat is directly heating at 90 degree where sun heat is more, and then other area the angle of sun's rays is 45, 60 or 90 where sun's heat is received less. So here we know there are two main causes for season. One is the distance between the sun and the earth doesn't remain static while it revolves around the sun. When earth revolves around the sun, sometimes distance is close, sometimes distance is large. That is one reason. Other one is angle. The sun's rays hit the earth's surface. When the sun's rays hit the earth's surface, the angle of heating the earth's surface is different. 90 degree, then heat is more, and uh, below 90 degree, then heat is less. Next we have solstices and equinox. The day on which the midday sun is vertically overhead at the Tropic of Cancer or the Tropic of Capricorn is called a solstice. Do you remember what latitude is known as Tropic of Cancer and Tropic of Capricorn? Tropic of Cancer is the latitude which is 23 half degree latitude on the northern hemisphere is Tropic of Cancer, and Tropic of Capricorn is the latitude which is having 23 half degree latitude in the southern hemisphere. When midday sun is directly overheating over this Tropic of Cancer and Tropic of Capricorn, that is at 90 degree, then we have solstice. It is the longest day in the hemisphere. That means when there is solstice on the northern hemisphere, that means sun's rays is hitting over the Tropic of Cancer, directly hitting over the Tropic of Cancer. Then daytime is longer than nighttime in the northern hemisphere, and when there is heating of sun's rays directly over the Tropic of Capricorn, then we have solstice again in the southern hemisphere. In that time, day is longer in the southern hemisphere. So there are two solstices in a year. They are summer solstice and winter solstice. Similarly, on the days of the year, the midday sun is vertically overhead at the equator. On these days, the duration of days and nights is same throughout the world. These days are called equinox, and we have two equinoxes, spring equinox and autumnal equinox. So you know that solstice and equinox different. Solstice when there is sun's rays directly overheating at the Tropic of Cancer or Tropic of Capricorn. In that time, daytime is longer. And then Equinox happen when sun's rays is directly overheating at equator, and there will be same day and night. Next we come to some more point. Major part of the northern hemisphere receives sun rays, making the days here longer than the night. That means during this solstice time. It is summer in the northern hemisphere and winter in the southern hemisphere. So summer solstice, the sun's rays fall vertically on the Tropic of Cancer, and the northern hemisphere experiences the longest day and the shortest night, and the southern hemisphere experiences the shortest day and the longest night, alternate to each other. And we have winter solstice. Please observe the position of the earth on the 2nd December in the figure given below. This is the picture showing winter solstice. The south pole is inclined towards the sun and the north pole is away from it. That means south pole is closer to the sun as compared to the north pole. Major part of the southern hemisphere receives sun's rays, making the day here longer than the night. In the summer, in southern hemisphere and winter in the northern hemisphere. So in this position, southern hemisphere experience summer and northern hemisphere experience winter. So on winter solstice, sun's rays fall vertically over the Tropic of Capricorn. The southern hemisphere experience the longest day and the shortest night. The northern hemisphere experience the shortest day and the longest night. Next, we have spring equinox and autumnal equinox. As you know, equinox, sun's rays is hitting directly over the equator, so day and night is equal in length. And we have spring equinox here, that is on 21st March, and we have autumnal equinox, that is September 23rd. And here is a picture to show summer solstice, winter solstice, spring equinox, autumnal equinox. So this picture is showing the position of the earth around the sun. Position of the earth around the sun, which shows in what position winter solstice occur, in what position summer solstice occur, and what position spring and autumnal equinox occur. This picture show the position during which this equinox and solstice occur. With this, we end up here.